In our last video, we talked about how the kidneys filtered out blood by running it through a nephron. Remember, the nephron is made of a capsule of blood vessels surrounded by a glomulus capsule, and all of this, the whole thing, is called the renal corpuscle. Blood would enter the renal corpuscle, be filtered, and the potential waste would be ran through a series of tubes: the proximal convoluted tubule, the loop of Henle, and the distal convoluted tubule. Through these different tubes, electrolytes, fluids, and other chemicals like glucose and urea are reabsorbed as needed, and then the waste is excreted as urine. So, two questions you might have on this. How do the kidneys know how much to reabsorb, and where does that urine go? Well, we've actually talked about the answer to the first one way back when we discussed the endocrine system. Antidiuretic hormone, which is secreted by your posterior pituitary gland, causes us to retain salts and fluid, which decreases the amount of urine produced. There's also another chemical called aldosterone, which is secreted by the adrenals, and that causes us to reabsorb water, again, decreasing the amount of urine that we produce. On the flip side of that, atrial natriuretic hormone, or ANH, is secreted by atrial tissue in the heart, and that causes us to reabsorb less sodium and fluid, and that gets us to make more urine. So just to kind of paraphrase it, we have antidiuretic hormone and aldosterone on one side, and that's causing us to hold on to salt, which in turn holds on to fluid, and that's balanced out by the ANH on the other side, which causes us to let go of salt and let go of fluid. And this is keeping our fluids in a balance, or homeostasis. All right, easy. Now, question number 2, where does the urine go? So after leaving the kidneys, it goes through the renal pelvis, and then it'll eventually make its way to these large tubes called ureters. These tubes will run from the kidneys into the peritoneal cavity and eventually into a large holding sac called the bladder. So the bladder is made of transitional epithelial tissue, which allows it to stretch depending on how much urine is inside. So this stretch function is actually really, really important, as we have stretch receptors on the outside of the bladder that'll tell us when it's full. So as it stretches, fills up with urine, that's where we get that sensation that we need to pee. So if you look at the image of the bladder, you might think it looks really familiar. It's very similar to the inside of the stomach, and you wouldn't be wrong there. It's got an inner mucosa layer, and in that mucosa you can see the same rugae or folds that the stomach has. Its middle layer is this muscular layer that squeezes and helps excrete the contents. In the stomach's case, it was stomach acid and chyme. In this case, it's urine. Luckily, though, the bladder doesn't make stomach acid. So, leaving our bladder, we have two sphincters, an internal and an external sphincter. The internal one is involuntary, but the external one we can control, which is how we hold it through long car rides or when we're in anatomy class. Last thing to take note of about the bladder, take a look at that prostate gland there. It sits just around the ureters. We'll talk about it a little bit more in our reproductive system lesson, but note that the ureter runs directly through the prostate. This can become problematic, especially in men, as they're more prone to having enlarged prostates, which can cause issues excreting urine.